Alright, we've made it over here to the pacemaker and just getting it set up now. And you can see I got just barely enough room to swing this, but it is going to work, and I've actually already run the carriage up to make sure that it's going to miss the saddle, this jaw right here, and we do have some clearance there. So we're going to be good as long as it holds good. So this being casting, it's going to be a little difficult to indicate, but what we want to do is just make it even. So we want to try to get it, you know, two jaws on the indicator running about the same position across these two jaws here, same position on the indicator. No matter if it's high or low, we just want to get it on the same number. I'm going to use a wide button nose tip on the indicator there. Alright, so that side's already telling us that we're low there. So I'm just looking at the number there. We're at 51, and what we want to do is just try to make each side even. And this side's definitely low too, so this is our high side right here. This area right in here. So let's see. Alright, I'm going to go ahead and that's in a bad spot right there to be able to see. Try to get these two sides as close as I can first. That's not bad. That's within 5 thousandths side to side, but we need to check this side and this side. I'm gonna have to move the indicator. Around 30, and that spot's 50, so. I'm having to use these points of reference on each side of the jaw since there's a cavity right there. 35, 40, it's still a little high. See if I can tap this one, not move it too far. You're gonna try not to go too far with it. Alright, I think we're going to be close enough to start doing our face in there. I'm going to say we're within 5 thousandths. Alright, that's our initial face indication right there, but we still need to get the center true. Alright, so let's go ahead and work on that. So here's how we're going to get the bore trued up. I'm going to use the old piece as a pattern to be able to indicate on. So we're going to bolt that to this one right here, and then we're going to indicate this ID. Now unfortunately I can't get all the bolts in here just because it's off a few thousandths from a 14mm bolt being able to go through them. They're drilled so precise that this old broke casting is just not lining up perfectly. But I can get 3 of them in here, which is going to be suitable for what we're doing. So there's one, that one right there, and you see, I mean, it's close. You can also get one more in this one, but I have to like thread it in there. It's so close that you have to just screw it in there. Alright, I got some hex nuts that we'll put on here and just snug it up. We're just wanting to hold it, keep it from shifting around, and then we'll get in here with our ID attachment and indicate that bore. Now even this bore is going to be a little tricky to indicate. We just have to average it out because of the crack in it, and I can feel with my fingernail that whenever I glued it back together that it's not seated exactly perfect. Pretty far off. I'm just working a little at a time. I don't want to make any big drastic moves on this thing and make it where it's going to slip and fall out anywhere. All right, so it's going to take a little time, but we're going to get it there. It's all part of it. So I'm on the inside, so in this case I'm loosening my highs, tightening my lows. Alright, so those two jaws there are pretty well even. Now let's check the side. Pretty close. I think that's going to be close enough for what we're doing right there. I'm going to call that being running true. That is going to work right there. So what we're going to have to do, I'm not going to show all this. I'm going to have to take this piece back off, indicate the face again to make sure that it didn't twist and move around, bump it true if we need to, go back on with this piece again, and then re-indicate this again. Got to keep doing that until you know that you're good and straight and true. Alright, that was our initial touch off. I'm going to bring it all the way to the outside and then give it a nice face cut. Alright, so we know we're going to clear there. We got quite a bit to come off. I'm going to take easy cuts on this. It's going to be 25 thousandths. Definitely getting into some hard stuff there. Alright, I already got that first tip there, so I'm running it too fast, but it's going to be hard, man. I've got some different inserts to try. That's one of my good inserts there for tough materials and interrupted cuts. But I've also got a ceramic insert that we may have to try and see if it'll work too. That stuff's super hard, man. That insert ain't lasting. I'm gonna have to try another one. We've got that ceramic, and I've got a PCD insert also. Just trying to get through that cut. I got a ceramic insert in there now, so we'll see if that lasts or if it works or not. ceramic seemed to work. I hope it continues, but it's chipping out all the sides. I'm not liking that. I hope we can get it cleaned up. Still got a little bit out here on this outer side that we got to do. I think we might be getting down to our final cuts there. Got to see, getting close to that outer tip. I think we finally got it. There's one little low spot right there. I think we may be okay with that. It's spaced all the way around that bolt hole there, so we're gonna leave it just like it is. So we're gonna call our face done, and we'll go to our inner bore now. Okay, our face actually looks really good, so we're gonna move on to the bore. We got a 2-inch boring bar in here. I'm going to try my normal cast iron inserts there and see. I put a file right here on this and it didn't seem like it was that hard, so I'm hoping this center section maybe is a little softer, but we'll see. Let's just get it round. We got to bore this to 65 millimeters, and then we've got a counter bore of 90 millimeters by 9 millimeter deep. It's not acting like it's hard right there, but I'm not going to say that it's not. Let's just keep going with it, and hopefully we'll have some good luck in here. After that pass, we'll go ahead and get a measurement, see where we're at. Can't get all the way up in there, but I can get right on it and see about where we're at. It looks like we're just over 55 millimeters. We got not quite 10 millimeters to come out of it. I'm real happy with the way this bore is turning out. It's not super hard like the other parts of the casting. All right, let's see where we're at on our bore here. Well, let's try to get it properly here. So we're going to go to 65 millimeter. For you metric lovers, that's going to be 2.559 inches. Right now we're at 2.430. So about 120, 130 thou to come out of it. So we'll get it there. Alright, we should be able to make some finished cuts here for this journal. 2.529, so we have 30 thousandths to come out of. I'm going to do 2 cuts, we're going to do 15 and then mic it, take the remainder out of there. At 46 that time. So we're going to take 12 thousandths for our final cut. Alright, let's see if I hit it. I was shooting for 558. it looks like I got 558 and a half. So half thou over what I wanted. That's perfectly okay. Just double checking it. I always double check it. Yep. Looks like I overshot it by half a thousandths. So that's our 65 millimeter bore for our oil seal. Let me grab it and show you. All right, so there's our new oil seal. That's going to get pressed in from the other side though, so it's going to fit that bore there. Okay. Now we got to do our counter bore right here, and that's for this bearing race here, Timken bearing race, where it's going to fit it just like so. 9 millimeter deep, 90 millimeter on the OD right here. So we're going to get touched off on our face so that we can set our depth. All right, 9 millimeters. We're going to go 350 thousandths deep. That'll give me about 5 thousandths to clean the face inside of it up. Getting an idea where we're at on our map here. Still got 400 thousandths to come out of there, so it looks like it's going to clean it up very good. Finish it out using our SPI tri-mic. There's 3.5 on the 0. 1, 2, 3, 4. So we're right on the 3.505 on our size. So they want this 1,000 slip fit, this bearing race inside the bore there. So I'm micing it to see where it's at. And I'm getting 543, 3.543. And double check it. .543. So we want our bore 544. And give it 1 thou slip fit over this. It's a cap just to capture this bearing and keep it in place and hold it where it's supposed to be. All right, so that'll give us about 40 thousandths to come out. It's a 20 thou cut. All right, so these are a little bit tricky to read if you're not used to reading them every single day. All right, so 10, 20, 25. We're at 326. 326. see if we hit my mark. 344. At about a half over. I think we're gonna live with that though. That's what they want right there. Just giving the depth a check here. All right, we're good on that. We're 9 millimeters deep. So chamfer this edge, chamfer this edge. The back side I'm not going to chamfer because that face isn't true with the bore, so it cut heavy on one side. I'm going to use a flat disc to chamfer the other side there and make it look consistent all the way around. Man, I am happy to get to this point right here. I feel much more relieved knowing that it did machine and we were able to salvage this casting and make it work. So, man, sizes turned out where we wanted. We got a good face on there. So all we got left to do is we got to go to the mill. There's a little 1/4 inch wide slot right here just for oil to pass through. So I need to mill that part out right there. And then we also still have the 2 holes here and here that I got to drill, and really hoping that's not going to give me a problem, but I'm a little bit worried about tapping on the back side. We may have to sacrifice a tap to get the threads in there, so we'll see how that goes. Let's go ahead and take it out of here. There it is. All right, we made it over here to the Bridgeport. I've got everything lined up. That's what was left of the slot. That's why I didn't fill it all the way in, so I'd have something to just line up on. It's just an oil passage is all it is. So we're gonna go ahead and try to cut that with this old raggedy 1/4 inch end mill. I'm gonna touch it off and just step it off with some cuts. It's 7/16 deep. It's 250 deep right there. It survived. Look at that. All right. Let's go ahead and finish it out. We'll go to 437 now. There it is. I'm just hand feeding this thing. There ain't a lot to do here. Found some hard stuff somewhere in there. We got it. Yep, looks like that'll work right there. There's a little better shot of what we did. And by the way, I'm pulling down on the 3 points of contact on the other side of the casting there. I'm using the brass shims just so that we don't mar up our new face. All right, we got her bolted down, clamped on 3 sides, and we're going to line up these 2 holes with our drill bit and hopefully get them drilled and tapped. Those keyless chucks, man. Whenever you go to move this thing, it loosens it up. I'm lining it up with a letter R drill, 339 thousandths. That's tap size for a 1/8 pipe. That's what these are, 1/8 pipe. But I'm going to use a 5/16 carbide drill right here to go ahead and get that hole drilled down through there. So these are those straight flute carbide drills. Work really good. Taking it easy there, letting the drill try to keep itself centered. I'm going to use a knee to bring it up. Okay. You got to be careful coming down through something like that. That drill catches it, it could break the end of the drill there. Let's see if my letter R drill will drill it. Getting close. I'm on the last 2 features now, these 2 holes. Hear how hard it is when you go into it? Now listen to it when it comes through the backside. Alright, we got her clamped down. I lined the hole up with the drill bit and I went ahead and chamfered it, trying to remove some of that harder crust on the outside. So we got our 1/8 MPT tap. Let's see if I can tap this. It's just a cap that goes in this thing right here. Yeah, it looks like it feels like it's doing fine. I'll go get a couple plugs because that's what goes in it. It's just some pipe plugs. I'm not sure of the exact use, I just know that it's for oil. I don't know what they use the holes for. That looks like that did fine though. We just try to chamfer those holes to where it gets rid of that hard crust right on the outer and the tap isn't trying to cut into it. All right, we got that one in there and that one looks good. I'm gonna run this tap in this one more time and try to get another thread or 2 out of that one, but other than that, this thing, I need to flap this edge right here, get rid of that sharp edge, and it'll be ready. All right, everybody, there it is. It's all completed and ready to go. I'm glad to see this one completed. As I usually say, always glad to see them completed. So I went ahead and flapped this inner diameter right here, this edge, softened it up with a flap disc, softened the outer edge up a little bit, just the same. So it actually machined out pretty good. It did better than what I expected it to do once we started our facing cuts and our boring in here. But you can see it did pretty good. I'm happy that we got a suitable replacement part for this box now. And I want to thank my friend Clark Easterling over at Windy Hill Foundry for jumping on this and getting this done for me. Really appreciate his efforts in that. So there we have it. There's the old one for comparison. And of course we got our solid one there too. So here's the completed gearbox with the replacement casting piece that I made, which is right there. See it? It worked out really good. Worked out fine with no problems. The guys got that finished up, built, tested, painted, and ready to ship out. Here's the other casting that I used for the pattern as well. Nice looking Hanson producer right there.